Now we will be discussing on modulo K counter problems. This is the third method of DFA design technique. According to me, it is one of the easiest method to construct the DFA. It follows 3 steps. Those 3 steps are: step 1, identify number of states. Step 2 is identify initial and final state. Step 3 is design. There is nothing here problem. Let us take the problem 1 in the textbook, which is given here. You can see in the textbook, L is equal to, let us obtain a DFA that accepts string of even number of A's. The DFA can be constructed by following the step one by one as follows. The question is, construct a DFA which accepts even number of A. I will be writing here, construct a DFA which accepts, which contains even number of A's. We have to write a DFA which contains even number of A's. The number of A's in a string should always be even. That is, it can be 0, it can be 2, it can be 4, it can be 6, it cannot be 1, it cannot be 3, it cannot be 5, and so on. You may wonder, what is this syntax? There is no much difficult in this syntax. That is, L means language is equal to string. String is represented by W. I will put colon here, and explain what W is. W is a string which contains even number of A's. Here L means language, W represent string. This part after the colon gives what does the string should contain. Now let's do the problem. What is step 1? Identify number of states. Since there are even states and odd states, there is only 2 states, that is even state and odd state. I have completed with the step 1, identifying number of state. Let's go for step 2, identify initial and final state. Generally, initially the language, this can be expanded as L is equal to psi, which contain even number of A's. Means it can contain 0. 0 is also even number. So I write here psi, and I write AA. Here is 2, 4, 6 and so on. Initially it contains 0 number of A's. So initial state will be even. 0 means is a even number. So this is an initial state. We put an arrow mark to the E. After this, when it is in even state, take an example of a string which is in even state, that is AA. Contain 2 A's and it is in even state. If you give another A, what it has to do? It should not expect. It is not present in the language. So this string should not be accepted by the automata. So it changes the state from even state to odd state when A is given as an input. When A is given, it is in an odd state, and later I will add one more A. Then what happens? From odd state it comes to even state. And I forgot to tell about the final state. Final state is the result, that is the answer we want. That is, we want even number of A's. So make even number state as final state, and this is how the automata is constructed.